Hello and welcome to this lesson on designing Android UI components in XML using Android XML vocabulary for views, widgets, graphics, and layouts. In this lesson, we will cover the basics of designing UI components in XML for Android applications. We will also take a look at how those definitions in XML can be accessed in runtime. XML stands for Extensible Markup Language, and is a markup language that defines a set of rules for encoding documents in a format which is both human readable and machine readable. This allows us to easily construct UI components that are later interpreted by the Android system and converted into visual UI objects. The WYSIWYG editor in Android Studio also interprets these XML files live to render previews of our UI on a multitude of different screens, Android versions, and other configurations. In Android, XML files are used for a wide variety of purposes, in addition to creating the UI layouts which we have previously discussed. XML files can also be used to define string constants, which are normally stored in values/strings.xml. Strings.xml files allow for easy update of string constants and effortless multi-language implementations. XML files can be used to define dynamic graphical asset references, for instance, different drawable assets for different states of a view, like pressed or clicked. In Android application development, a common user interface component is the menu, whether it be by a menu from the app bar of the application or a floating context-based menu. In the case of menus, the menu items can easily be defined in XML format and allow for the full power of the resource system to decide which menu to use for which specific occasion. When designing animations for views in our applications, we can easily create XML assets that define and configure these animations for using in runtime. When designing the look and feel of the application, it is important to define the overall style. A valuable way to define aspects like styles, themes, and color schemes is in XML files that can then be applied to parts or the whole of our applications. In addition, predefined values for booleans, dimensions, and array properties can be defined in XML resources. These values can be used for default settings or desired paddings and margins for different devices running our application. In Android Studio, we have the powerful Layout Editor tool to assist us in designing the XML for our UI components, whether they be complete screen layouts or smaller aspects of certain screens. The drag and drop style building allows us to quickly prototype a desired visual component, which the layout editor converts on the fly to XML. We can then switch the XML view of the file and edit aspects of the layout more precisely and tailor it to our precise needs for the application. One of the enhancements we receive with the Android Studio Layout Editor is the ability to preview our UI components on many different screen sizes, different screen dimensions, and proportions. This way we can ensure that our XML will be compatible with all desired target screens for our application. The enhancements don't stop there, however, and we can even change the locale for our UI previews and ensure that our UI is as expected for different locales and languages. This allows us to preview different string constants and assets tied to specific locales easily by changing the locale in our preview. Android operating system has progressed through many different versions, which have included UI updates and changes. In the Advanced Layout Editor, we can preview our XML for different versions of Android to ensure that what we have designed can look great on all of our targeted Android versions. When a layout XML asset is loaded, Android initiates each component of the layout into a runtime object, which in most cases would be some type of view like a text view or a button. Once these objects are initialized, we can retrieve them in our Java code by calling the method findViewById, which receives an int as a parameter. This will normally be done in our activity class, but must be done after the XML resources have been loaded. The int parameter from the findViewById method call is a reference that is listed in the r.java file that is auto-generated by the Android build systems. This r.java file creates the linkage we need between our XML code and our Java code in runtime and allows us to access our pre-designed UI elements in the application runtime. We will now take a look at how this is done in Android Studio. We'll start by opening our Hello World example application that we created in our previous Hello World lesson and following lab exercise. Once you have opened the example from our Hello World app, open the activity main XML. In case your XML opened in the text XML view, which it did here, click on the Design tab at the bottom window so that we can use a drag and drop design viewer. When in design mode, we can drag and drop elements from our palette to the current screen. Let's drag a button onto our screen. We see when we drag a new element to the screen close to another element, green arrows are drawn from this new element to our previous text view. These green arrows represent the relative placement of our new button to the previous text. We will learn about relative layouts and the arrangement of views in relative layouts in a later lesson. Now let's switch over to our XML view. We can see that a new button has been added to the XML, already with pre-configured margins and parameters to place it below our text view. Now let's copy that button element and add another button below and to the right of that one. We will notice that Android Studio has highlighted an error in our file in red. This is an ID conflict because both of our buttons have the same ID parameter. So let's change the ID of our second button to button 2. Okay, now in order for this button to be relatively below and to the right of our previous button, we need to change the below parameter from ID my text view to ID button. We also need to add another attribute for to the right of, and add again our ID button. In order to differentiate between the two buttons, let's change the text of the second button to new button 2. Now we can go back to the design view by clicking the design tab, and we'll see the addition of a new button we added in our XML code. Now we can click on that second button in our design view and simply press the delete key. Now if we return to our XML view, we see that the second element has been removed because we deleted it from our design view. Now we can go back to the design tab and we see only our first button and our original text view. In the same fashion, we can go back into our XML view and delete our first button. Now when we return to our design tab, we see that the first button has been removed as well. This way we can easily design and implement UI components by using either the WYSIWYG drag and drop design editor or using the plain text XML view of our UI. In most cases, we will need to use both of these editors to get the perfected UI components that we require for our applications. Once we have our UI designed through our layout editor, we can preview how it would look on different devices to ensure our design's quality on that range of devices. By clicking the device selector pull down, we can select another device preview of our XML. Let's select a tablet device to see how our UI will look on a screen proportion of a tablet. We can see the outline for the preview and things like text and view size in relation to screen sizes have changed to allow us to preview how our UI would look on a tablet. In the same fashion, we can see how our UI would handle a device orientation change by clicking the orientation selector. Now in landscape, we can see how our screen would look on the landscape mode of a tablet, in this case, a Nexus 7. As we previously mentioned, themes allow us to stylize parts or the whole of our application. If we click on the theme selector, we can see how this UI would look with a different theme applied. We notice that we only have one default project theme that was created when we started our project, but there are also some pre-made Android themes that we can use for application. Let's take a look at the Hollow Light themes. Let's see how our XML would look when we apply the Hollow Light No Action Bar view. We see that not only has this removed the action bar, but it also changed the background color and the color for our text. Now let's see how we can change items from this view in runtime. Let's open our main activity.java file now. From our previous Hello World lesson, we already grabbed the text view for the XML we loaded into main activity. This allows us to dynamically change all different types of properties of the text view, like the text it displays. Let's add another line after grabbing our text view to set the text to Hello Again. Now when we run the application, we see that the application starts up, and although the text view should have "Hello World" that we defined in our XML, it shows the hello again we dynamically set in our onCreate method of our activity. Thank you for joining us in this lesson on designing UI through XML and Android. Join us in our next lesson where we take a closer look at views, view groups, and layouts.